In this second part of the tutorial, we will show you how to complete the data collection by adding information from available monitoring data. Furthermore, we will show which results are available in order to analyze the present state energy consumption. In order to follow this part of the tutorial, you can either continue with your project from part 1 or alternatively load a project from your computer. I will show you how to do this. So you select Project Import and open the folder where you have this example project, and you select demoTFC Step 1 Base Case and open the project. In the present showcase, it is supposed that the only available information on the schedules of processes in time are available monitoring data, which nevertheless are not directly monitoring the process's operation. The available monitored data are the steam generation in the steam boiler supplying both processes and the hourly production volume of the final product. First, we load the available data for steam generation. We open the 3-item monitoring data and add a new entry data row. By right-click, we load a new data file into our project. In your example, this is demoTFC data 2 megawatt.csv. And we select the column steam in this data file. The input data correspond to the system parameter of equipment steam boiler. So you select here useful supply heat supplied by equipment. And it's a steam boiler. And you click OK. For loading the available information on production volume, we add a new row to this table. So again, by right-click, you can take over the already loaded data file, and we now select the column Product. So input data correspond to the system parameter production quantity, and the object is some product. In order to take into account that in the future the volume of production will grow by 25% with respect to the recorded data from the past, we can scale furthermore the monitoring data by the factor 1.25. And finally, confirm the data by clicking OK. Now we link the production volume of some product to the quantity of cooling water from the waste heat generating process. We suppose that those quantities are correlated by a constant ratio. We open the editor for mass flows in the system. Add a node by right-clicking and select Scale Mixer. We enter the ratio of product to cooling water of 0.503, and we delete the rows in this table which are not needed. Then we connect the cooling water to the input of this node. and the output of this node to the product. As a last step, we modify the operation schedules of the processes. For this purpose, we open first the waste heat generating process. And within the schedule, we change the schedule type from simple to fit to data. And we repeat the same thing for the low pressure steam. Now we can run again our consistency and completeness check. And we can see that all is okay, so we can confirm the data as a valid reference scenario for the present state by clicking OK. Now we will show you some of the detailed information you can obtain from EINSTEIN on the present state energy consumption. First of all, you see the share of each of the processes in the total heat demand. In a second breakdown, you see the cumulative heat demand as a function of temperature. In a graphical form and in a tabular form. As a third breakdown, you see the cumulative heat demand by time. Furthermore, you can see the final energy consumption by equipment, by fuels, and the corresponding primary energy demand. An overview of the yearly energy flows in the system is given in the system scheme. You can hear the energy flows at the input and the output of each block. And you can see the monthly breakdown of demand and hourly data. Pinch analysis is automatically carried out. You can see an overview of the hot and cold streams in the system. The hot and cold composite curves. The ground composite curve. And some aggregate summary results of the heat recovery potential.